Hello my friends and welcome back to the You Can Do TV channel.
At Officina Meccanica di Mara Giamario and CSRL, high-precision, large-scale machining is powered by the PAMA VERTIRAM 5600, a state-of-the-art gantry-type vertical machining center designed for complex heavy-duty operations. With a massive X-axis stroke of 10,000 mm, Y-axis of 100 mm, and Z-axis travel of 2,000 mm, the VERTIRAM 5600 is built to handle oversized components with exceptional accuracy. This machine is equipped with full hydrostatic guideways, offering superior damping and stability across all axes. The spindle delivers 103 kilowatts of continuous power at 4,000 RPM, supported by a rigid 590 by 590 mm ram section, ensuring minimal deflection during deep or high-load cuts. The adjustable W-axis crossrail further enhances flexibility for varied part heights. Controlled via advanced CNC systems, the VERTIRAM 5600 enables 5-axis simultaneous machining, tight tolerance control, and automated tool paths for efficient processing of turbine cases, structural molds, and aerospace assemblies. Its high rigidity and thermal compensation system allow the machine to maintain accuracy across long cycles. This investment demonstrates Officina Mara's commitment to cutting-edge manufacturing, combining Italian craftsmanship with PAMA's renowned innovation in large-format machining. PEAF. Hybrid power and precision combine as painting propeller equips the Fasmer shipyard patrol boats for the German Federal Police. The 5-blade controllable pitch propellers are installed with full control systems and transmissions. Hydrodynamically optimized components reduce resistance and improve efficiency, while the hybrid drive allows future switch from oil to water hydraulics. Each propeller is engineered for 30+ years of reliable operation, minimizing maintenance. Collaboration between the shipyard and Peening ensures a system that is service-friendly and replaceable. It's interesting to see such compact engineering handling a vessel this size, almost like the propeller thinks ahead for the crew.
From a sea of steel plates rises the LNG carrier Asterix 1, built at Hyundai Heavy Industries with unmatched scale and speed. Each piece is welded into massive hull sections before being lifted by cranes into the dry dock for assembly. The structure grows as outfitting continues, pipelines, insulation, and gas tanks fitted within the reinforced shell. Enian. Every move looks deliberate, yet the pace is astonishing for such a colossal vessel. Crews install propulsion systems and electrical wiring, ensuring the ship's performance at sea. You wouldn't guess this ship started as scattered steel panels. Once the decks and bridge are set, painting and inspection give the vessel its final finish. In still Pro Chi way. The Asterix 1 then undergoes sea trials to verify every system. Built for capital gas, it embodies engineering discipline and industrial might. Projects like this remind how human skill and technology converge on a monumental scale. DNN. Anchoring a vessel isn't just about dropping metal into the sea. It's a precise operation that defines safety and control. Each move here feels like part of a quiet conversation between steel and sea. On this training deck, crew members rehearse every motion before they ever reach open water. Chains rattle, commands echo, and coordination become second nature. The anchor, though silent, holds authority over the entire ship. Even before it touches the seabed, tension builds like an invisible test of discipline. Every shackle and rope section has a measured weight, ensuring balance through every stage. One small hesitation here could ripple through the entire process. The officer signals, and the anchor brake eases with controlled pressure. It's not speed that matters, but timing. The sea doesn't forgive guesswork. N. When the anchor hits bottom, the movement halts instantly, a quiet sign of success. Feels like the ocean itself just nodded in agreement. The crew reviews, checks alignment, and resets for retrieval. Every glance shared among them carries that mix of relief and readiness. Anchoring awareness isn't about repetition, it's mastery of attention. Layers of fiberglass are laid into precise molds at the Sea Hunt Boats factory, forming the hulls that define each vessel's strength. The resin is rolled evenly to remove air pockets, ensuring a seamless finish. Once cured, the hull is released and trimmed to prepare for assembly. That cut always looks cleaner than you'd expect. The deck is bonded to the hull using heavy-duty adhesives and stainless steel fasteners, creating a watertight seal. Technicians inspect the joint closely before moving on. It's wild how neatly everything fits together. Next, the wiring harnesses, fuel lines, and hydraulic systems are installed. Every wire is routed cleanly through the channels to prevent chafing. Engines are then mounted carefully onto the reinforced transom. That moment when the engine goes on just hits different. Interior components like seats, consoles, and windshields are fitted next, followed by the installation of navigation equipment. You can almost smell the new boat feel already. Finally, each Sea Hunt boat undergoes a rigorous water test to verify stability, performance, and durability before it's delivered. Seeing it glide on water after all that effort feels awesome. Quality and craftsmanship define every step, and that's what makes a Sea Hunt boat special. Pure satisfaction right there. Oversized trucks pivot 90 degrees on tight industrial roads with controlled adjustments. Drivers coordinate with spotters to ensure that the long trailers clear obstacles without incident. Hydraulic steering systems adjust the trailer's rear axles to maintain stability during rotation. The level of control needed to pivot such a long vehicle on limited space is astonishing. Tires grind slightly against asphalt as the truck maneuvers, but alignment is maintained. Spotters give hand signals, guiding the truck while monitoring overhead clearances. One can't help but admire the driver's skill and anticipation throughout each turn. After completion, the truck continues its route, maintaining precise lane positioning and overall cargo safety. Few operations attempt a 680-ton lift with this level of calm control. At Bechtel Gladstone, a 680-ton carbon dioxide absorber becomes the focus of one of Australia's largest construction lifts. The move requires precise coordination between two cranes, CC 6800 and CC 2800, each handling nearly half the load. Before lifting, the absorber is secured on SPMTs and transported down a narrow haul road to the crane pads. Every turn, shackle, and sling is calculated to millimeters. When the cranes engage, the absorber slowly tilts upward, rising to a vertical position in complete control. The hardest work happens long before the lift itself, planning every detail so the massive structure can settle safely onto its foundation. Every ro-ro ship at the Port of Baltimore is designed to move vehicles swiftly and safely. Each car, bus, or heavy truck is driven directly onto specialized decks of the ro-ro vessel. Strong lashing straps secure every wheel to keep cargo stable at sea. Once the ship is full, ramps lift and lock before departure. Simple idea, but such a massive operation. When the ship docks overseas, everything rolls off just as smoothly. On the Port of Baltimore, massive steel coils are lifted onto a bulk carrier, showing the complexity of heavy cargo handling at sea. Steel coils are lifted by a shipboard crane, each coil secured with heavy-duty slings. The crane operator raises the coil steadily, monitoring its balance as the rigging keeps it aligned. The coordination between crane and riggers is impressive. As the coil ascends, taglines guide its rotation to ensure the lifting points stay properly aligned. Once at deck height, the crane operator maneuvers the coil horizontally over the hatch opening. It's striking how smoothly such a massive coil glides through the air. Signals from deck personnel direct every minor adjustment, keeping the roll clear of obstacles and deck fittings. The coil rotates slowly when necessary to match the planned orientation for placement. End. During lateral movement, the crane shifts the load precisely above the designated spot. Every centimeter matters when tons of steel are suspended. The rigging team keeps constant tension on the slings to prevent sway, while the operator makes small incremental movements to maintain stability. As the coil approaches the target, final adjustments lower it gently, controlling speed to avoid sudden impacts. The timing and patience required are remarkable. Crew members guide the coil into alignment with the receiving deck area, using taglines and verbal signals, ensuring it lands exactly on its support points. Once positioned, the crane slowly releases tension on the slings, and the coil is fully supported by the deck. The entire lift demonstrates how machinery and human coordination handle heavy cargo safely. Each move, from initial lift to precise placement, is planned and executed with careful communication and attention to forces acting on the suspended coil. The process repeats for each steel coil, requiring repetition of lifts, rotations, and horizontal movements. Watching this in action shows the skill and synchronization of the team controlling the crane and slings. The operation highlights the importance of steady hands, precise control, and real-time adjustments. Every coil lifted and moved on deck emphasizes how much planning goes into preventing sway or collision. turning what could be a risky maneuver into a controlled, efficient operation. It's a display of teamwork and engineering working together to move heavy steel safely. The new Suez Canal stretches with monumental ambition, aiming to increase transit capacity between Europe and Asia. 7 Jan de Newell cutter suction dredgers, including JFJ de Newell and Leonardo da Vinci, operate with immense diesel power, slicing through compacted sand and rigid clay. Operators coordinate the massive machines, ensuring soil is dredged and relocated efficiently. The canal's planned depth of 24 meters and width of 240 meters requires precise alignment and continuous monitoring. Seeing these vessels glide through such challenging material makes you realize how engineering meets sheer scale. Deadlines are tight, and each cutter must maximize output while maintaining safety. Some loads shift like giant puzzles falling perfectly into place. The dredgers' coordination and raw power reflect why this fleet leads the world. Offshore waters on Malaysia's northeast coast host vessels that turn vision into action. The Sapura 1200 and Sapura 3500 execute complex offshore construction tasks, dynamically positioning and performing heavy lifts with remarkable control. Pipelay support vessels carry out pipe laying in ultra-deep waters 250 kilometers off Brazil's coast, achieving uptime rates near 99%. Subsea operations push the limits. The Typhoon ROV descends 2.5 kilometers to locate wellheads under immense pressure, operating where few machines can survive. Exploration, development, and production span from shallow to ultra-deep reservoirs, with rigs extracting hydrocarbons safely up to 30,000 feet. Operators monitor and adjust each vessel's systems continuously, ensuring optimal performance and safety. Teamwork and experience guide every mission, transforming knowledge into results that drive global energy supply. Sapura Energy recently added 9 trillion cubic feet of gas reserves offshore Malaysia. The scale of coordination is impressive, almost like orchestrating a mechanical symphony across oceans. Loyalty and skill remain the most critical assets, proving that advanced tools are only as effective as the people behind them. Seeing vessels operate in such harsh environments makes you realize energy progress relies on brains, brawn, and innovation combined. Thousands of feet below the Gulf of Mexico, Shell's deepwater rigs pierce the earth in pursuit of hidden energy. After seismic surveys map the subsurface, geoscientists select the safest path to target oil and gas deposits. Depending on water depth, the rig may be a drill ship, a semi-submersible, or part of a floating platform, each fitted with a hoisting system, a blowout preventer, BOP stack, and pumps for fluid circulation. That BOP looks like a small building hanging under the sea, N5-1. Drilling begins when the bit spuds in the seafloor, driving a large base pipe to stabilize soft sediment. That first entry into the seafloor always feels like the start of a marathon. The base pipe and wellhead are lowered until they reach proper depth, then drilling continues downward. Crew timing must be perfect. One slip in mud pressure could ruin the bore. As the hole deepens, drilling mud cools the bit, lifts rock cuttings, and balances pressure. That mud isn't just dirt, it's the lifeline of the whole system. When the target depth is reached, the bit is withdrawn, casing strings are installed, and cement is pumped to seal the layers. The cementing plug always finds its way like a guided missile. In deeper sections, the BOP stack and riser are attached to control any unexpected flow. The riser links the seabed to the rig, circulating mud and rock safely to the surface. That column of fluid stretches for miles, basically a moving pipeline inside the ocean. Pretty wild that something so thin controls so much power. Once the well reaches the oil or gas zone, the final casing ensures secure production. Each layer below becomes a story of risk, science, and timing. You start realizing this isn't just drilling, it's orchestrated pressure management. Bridging two historic waterways in Scotland, the Falkirk Wheel redefines canal transport with engineering grace. Its purpose is simple yet grand: to lift boats between the Forth and Clyde Canal and the Union Canal, separated by a 24-meter difference in height. It replaced 11 old locks that once linked Glasgow and Edinburgh, Nan. Two vast arms form a Celtic-inspired double-headed axe, rotating 180 degrees to raise and lower two water-filled gondolas. Each gondola holds up to 600 tons of boats and water, yet remains perfectly balanced. Hard to imagine something this massive turning with so little effort. That balance comes from Archimedes' principle. A boat displaces its own weight in water, so each side of the wheel always weighs the same. You could say the engineers turned physics into a smooth, slow-motion lift. Then in. Divers inspect the damaged sections of Baltic Ace, revealing the challenges for salvage teams. Rijkswaterstaat contracted Boskalis and Momoet Salvage to remove the Baltic Ace wreck, 65 kilometers off the Dutch coast. The 150 meters long, 25 meters wide ship sank with 417 cars on board, containing nearly 540,000 liters of oil. Imagine all that oil trapped under the sea, intense risk for marine traffic and environment. Salvage operations were split into two phases. Firstly, oil was removed using the hot tap method with heating elements, extracting over 456,000 liters from accessible tanks within 2 weeks. And after that, divers cut holes into the wreck to inspect structural damage. The ship was too damaged to lift in 6 sections, so plans changed to 8 sections using wire cutting systems 80 to 120 meters long, assisted by floating barges with heave compensation systems. The stern and bow were lifted first, the bow weighing 500 tons, followed by the remaining sections. Smaller debris and vehicles were cleared using a large salvage grab. Over 18 ships and 150 people participated, removing nearly 13,000 tons of wreckage. Janssen Recycling Group dismantled and sorted materials for recycling. The seabed was cleared, and the shipping lane reopened 2 months ahead. Absolutely massive operation executed efficiently. The Cavatliner system in Palermo's Molo Sud performs underwater cleaning in a way that turns heavy marine maintenance into a smooth, controlled operation. Mounted on a submerged frame, it moves along the hull surface to remove biofouling without damaging coatings. That steady motion underwater feels strangely calming. Using powerful suction and water jets, it detaches marine growth, then recovers debris through a closed filtration loop. N. The cleaned water is released back, leaving the sea clearer and the vessel more efficient. Less drag means less fuel, and that's real money saved per voyage. Operators above monitor through live video feeds, adjusting direction and pressure as the machine glides under the pier. Each run covers several square meters of hull surface, with minimal diver intervention. Automation at this scale proves how maintenance tech has matured far beyond scrubbing and scraping. Built to work even in murky harbor conditions, the Cavit Leaner keeps efficiency high and risks low. Hard not to admire how clean engineering meets ocean grit. By the end of the operation, the ship regains its hydrodynamic smoothness, ready for faster and cleaner voyages. Sometimes innovation doesn't roar, it just quietly keeps fleets running better.
What makes the Pressatech PierceTech slice through 20mm steel so effortlessly? The cutting head glides with controlled energy, piercing each sheet efficiently without warping. Operators adjust parameters to match the steel's thickness, ensuring optimal penetration. Sensors monitor each cut, maintaining consistent quality across every plate. The machine handles repetitive tasks with exact timing, eliminating material waste while preserving edge integrity. Alignment, feed rate, and nozzle distance are calibrated for flawless results. These edges are cleaner than expected. High-speed piercing and plasma control allow for minimal heat distortion, protecting the steel's structural properties. The workflow is surprisingly smooth for such heavy-duty processing, and the reliability of the PierceTech system shines in every operation. Each sheet emerges ready for its next stage in fabrication, demonstrating efficiency and consistency at a professional level. That cut went through like butter. Can't imagine doing this manually on 20mm steel. N.
El Greco's repair teams restore hull sections to full strength after grounding damage. The El Greco ship repairs team in Greece tackled 100 meters of hull damaged by grounding, deploying over 60 fabricators, welders, and engineers to work in shifts day and night. That many hands on one hull gives a sense of organized chaos turned productive. Damaged steel plates were cut away carefully, leaving clean edges for replacement. New metal sections were precisely shaped and positioned to match the original hull curvature. Welding followed, with every seam monitored for strength and watertight integrity. Seeing the ship regain its structure so quickly is satisfying in itself. Engineers double-checked alignment while fabricators adjusted plates for perfect fit. Temporary supports and scaffolding were used to stabilize the hull during the procedure. Teams rotated tasks efficiently, from measuring and cutting to welding and inspection. The repair workflow balanced speed with precision, ensuring the vessel could return to service promptly. That coordination looks deceptively simple, yet coordinating 60-plus people is no small feat. Finally, coatings and reinforcements were applied to protect the hull against future wear. Each repaired segment highlights expertise, endurance, and teamwork on a massive scale. It almost feels like watching a giant puzzle being solved piece by piece. The busy dock welcomes a vessel arriving for repair at MTG Dolphin, where engineers immediately begin visual and ultrasonic inspections. Initial assessments evaluate hull integrity and pinpoint sections needing maintenance. The immense size of the ship and the precision demanded impress everyone on site. Every detail matters when restoring a vessel of this scale. Steel plates are prepared and cut to fit damaged areas. Welding teams set up hydraulic rotators and cantilever platforms to handle heavy components safely. The sight of massive plates moving into place highlights both human skill and machine power. Watching the coordination of machinery and crews underscores the complexity of ship repair. Even small adjustments can have major impact on overall safety. Structural repairs begin with the replacement of corroded plates. Longitudinal and transverse seams are welded, ensuring the hull regains strength and stability. Automated systems lift and position each component, minimizing manual handling and reducing risk. The careful integration of robotics demonstrates advanced engineering solutions. Seeing the hull gradually restored is rewarding for the entire team. After welding, surfaces are ground and inspected for alignment and thickness. Anti-corrosion coatings are applied to protect the metal against future wear. Mechanical systems, including engines and propulsion units, are tested, disassembled if necessary, serviced, and reassembled. Each functional check confirms reliability before the ship returns to the sea. Finally, the vessel is prepared for relaunch, all repairs verified and documented. It is remarkable how coordination and technology converge to bring a ship back to life.
How does a vessel manage to refuel another without anchoring? With its 117-meter length and 7,686 cubic meters of tank capacity, this vessel performs transfers directly between ships. No port stop required. The operation begins as Kairos aligns beside a receiving vessel, connecting through 4 flexible manifolds for both liquid and vapor return. Its dual 900 kilowatts azimuth propulsion units keep it steady, even in strong currents. LNG flows at rates up to 250 cubic meters per hour, cutting downtime dramatically. That speed is wild for something this massive. It's like refueling a fleet in one go. The CNG tank at 220 bars stores return vapor safely, keeping emissions close to zero. The system's ballast-free design adds another environmental win, reducing water contamination risks. There's something oddly satisfying about seeing clean energy move this efficiently. From container ships to ferries, Nauticourse Kairos proves that heavy industry can indeed go light on emissions. Efficiency that feels both powerful and responsible. Now that's progress at sea.
Pipelines built for Nord Stream must endure high pressure deep below the Baltic Sea. Each pipe is produced under strict supervision, with steel plates tested for density and coating adherence. Every weld undergoes ultrasonic inspection to ensure there's not even a trace of leakage risk. The pipeline route is continuously monitored using advanced sensors during construction. You'd never expect so many layers of safety for a single pipeline stretch. On the pipelay vessel, robotic arms position and weld pipes seamlessly, ensuring uninterrupted gas flow. That mechanical rhythm looks hypnotic without meaning to. Each joint represents the balance between engineering reliability and environmental responsibility. Feels like watching the ocean meet human precision.
You can feel the tension as each massive crane segment is hoisted off the ship at Portobello. Dock workers and Mitsui E&S engineers synchronize every move to offload the two towering STS cranes safely. These massive structures have traveled by vessel from Japan and are now being offloaded piece by piece. A floating crane lifts the first giant piece of the ship's hull, slowly swinging it toward the dockside. Like a slow-motion ballet of once the first leg touches the ground, hydraulic screws secure it firmly in place. The next sections, trolley follow in exact order.
No way. Go to the pressure of the outside. Come to me. I just can't stay here.
Maintaining perfect coordination between ship crew and ground operators.
Stagnant under pressure.
Cranes like these are the backbone of
Let me guide you.
Vessel to
'Cause there ain't no way.
their reach extends over the width of the largest cargo.
Feel like taking over. 'Cause there ain't no way.
The size moves so smoothly feels unreal.
Let me guide you.
When assembly is complete, engineers inspect every bolt and joint, then connect the power systems that will soon drive each crane's trolley. The process ends not with fanfare, but quiet satisfaction, the kind known only to those who bring infrastructure to life. This is the kind of heavy engineering that keeps global trade breathing in.
The KEMROCKSI 12,000 cutter soil mixing attachment is mounted on heavy excavators to install in-situ soil cement diaphragm walls with minimal disturbance. As it advances, cementitious binder is injected at the bottom of the trench and blended upward with the surrounding soil by high-torque mixing chains, forming a homogeneous, impermeable soil cement barrier. The process progresses continuously, cutting, stabilizing, and sealing, resulting in accurate, durable diaphragm wall panels. In a powerful display of engineering excellence, the Liebherr LR13000, the world's most powerful conventional crawler crane, performs its first lift at the Ehingen plant. With transport-optimized assembly, modular components weighing up to 70 tons, and twin Liebherr 8-cylinder turbo diesel engines delivering 360 horsepower, this machine defines a new benchmark in heavy lifting. For this monumental task, a massive 60-meter boom is tasked with hoisting over 300 tons, supported by 400 tons of superstructure ballast and 500 tons of derrick ballast, totaling an astonishing 7,000 tons. The Dasu hydropower project, located on the Indus River in Kohistan district, Khyber Pakhtunkhwa, is one of Pakistan's most ambitious energy developments. Situated 350 kilometers north of Islamabad, the project is being executed in 2 stages, with a total planned capacity of 400 megawatts. Stage 1 includes 6 Francis turbines, generating 160 megawatts. The main dam, constructed from roller-compacted concrete, will stand 242 meters high, making it the tallest of its kind in the world upon completion. The project includes diversion tunnels, an underground powerhouse, transformer caverns, and a surface switchyard. China Geshuba Group Company (CGGC) serves as the main contractor. Once operational, Dasu is expected to generate over 21,000 gigawatt-hours of electricity annually, helping to eliminate power shortages across Pakistan. Beyond energy, the project will create thousands of jobs and support socioeconomic development through improved infrastructure and upliftment programs in the region.
Steel pontoons connect across the Indus at Daimar Basha Dam, forming a full bridge 60 days ahead of schedule. Each section is floated, aligned, and pinned in sequence. Crews secure the deck plates and side rails before vehicles roll across. Hard to believe this entire span came together so fast. Waves rock beneath, yet the bridge holds steady, a temporary but vital link in Pakistan's Decade of Dams project.
Each rip of the XR20 converts hard quartz into manageable debris efficiently at the Araniska site. The machine moves steadily across the terrain, guided by the operator to the target boulders. The force transmitted through the ripper's teeth shows exactly how engineering translates into controlled impact. As the XR20 engages the rock, hydraulic pistons drive the oscillating head, breaking down solid formations into smaller fragments. The operator monitors pressure gauges and ripper alignment, adjusting speed and angle to optimize penetration. It's clear that timing and placement matter as much as brute force. Taglines are not needed here. Precision comes from the combination of machine design and operator skill. The ripper advances slowly along the rock face, applying consistent pressure. Each strike is calculated, turning solid quartzite into transportable pieces. Fragments are pushed aside or collected for processing, while the ripper continues along the quarry line. The oscillation frequency is adapted depending on rock density, and vibration dampers minimize stress on the frame. The interaction between hydraulics and mechanics keeps the machine stable, even under extreme loads. Safety measures include keeping personnel at safe distances while observing the machine's path and ensuring the ripper's teeth remain intact. Operators communicate through hand signals and radio, synchronizing every move with attention to energy absorption and recoil. The machine demonstrates how technology can replace repetitive, hazardous manual labor. Throughout the day, XR20 maneuvers along multiple quartzite deposits, adjusting its position and depth for maximum efficiency. One can't help but admire how controlled yet powerful each action is. The operation highlights a synergy of engineering, material science, and human expertise, turning otherwise immovable rock into manageable fragments, while maintaining workflow and safety. An 8.5-meter TBM slicing through solid rock is a rare engineering feat. Heron Connect's Gripper TBM is engineered for the toughest hard rock conditions. Granite and basalt present no match as the 8.5-meter diameter cutterhead, loaded with 58 disc cutters, rotates under 32 tons of pressure per disc. The Gripper shoes extend laterally, bracing the machine against the previously excavated tunnel walls to maintain stability, while hydraulic thrust cylinders drive the head forward. Rock bolts, shotcrete, and steel ring beams secure the tunnel diameter, adapting to geological conditions. Integrated water jets minimize dust and cool the cutters, while sensor systems detect wear for timely maintenance. Excavated material slides via muck chutes into backup conveyors, keeping pace with the machine's advance. Telescopic partial shields, roof finger shields, and a robust invert shield ensure both safety and precise steering. Continuous monitoring and ISP-based geological prediction help anticipate weak zones or cavities. This is why underground infrastructure can be built at unprecedented speed. The way it grips and moves almost feels like the rock is negotiating with the machine.
Millions of cubic meters move through Linth Limern each day, turning water into stored power. Turbines drive generators as water rushes between the upper and lower reservoirs. When demand drops, the flow reverses. Pumps lift water back up. Every valve and gate synchronizes to control immense pressure. Engineers monitor from control rooms, keeping Switzerland's grid stable by storing and releasing energy when needed. Crazy that such calm mountains hide so much power beneath. And Nin.
How can a cable car feel open and safe at the same time? On the Stanzerhorn in Switzerland, the world's first cabrio gondola makes this possible. Traditional cable cars have overhead drive and suspension systems, but this gondola's innovative design positions them to the side, creating an open-top experience without compromising stability. Engineers from Doppelmayr/Garaventa developed the drive units, suspension, and safety systems to match this unusual layout. Each cabin glides along the line, guided precisely to ensure smooth travel, while passengers enjoy unobstructed alpine vistas. The combination of side-mounted traction and advanced suspension reduces vibrations and allows for gentle boarding and disembarking. This ride feels like flying over the Alps without leaving the ground. Never expected a cable car to feel this free and playful. NN. Concrete removal doesn't get trickier than this, an 80-feet silo standing just feet from an active farmhouse. A Brock 100 demolition robot, lifted by a telehandler, handles the task mid-air. Each strike breaks the wall inward, guiding debris safely inside. The operator monitors power and reach to keep every move contained. Seeing that much force stay perfectly controlled hits different. Most rubble collapses neatly, sparing the farmhouse from even the lightest impact. NN. Watching the Crest slag pot carrier swing and tip a red-hot pot is both nerve-wracking and impressive. First, it picks up a pot filled with liquid waste from the furnace bay and drives it to the dump area. Then it tilts and dumps the contents safely. The pot knock feature dislodges residual slag without damaging the vessel. It's wild seeing a carrier tip a giant container, and then knock out the slag like peeling an orange. Nin. After dumping, the machine returns, ready for the next load, with articulated steering allowing sharp turns in tight spaces. Its design lets it transport loads up to 150 tons with ease. Feels like this beast was built for the hottest jobs on the plant floor. Maintenance is simplified too. The tilting cab gives technicians easy access. Finally, each cycle stacks up, keeping the steelmaking operation cleaner and safer. Who knew slag removal could look so intense? Nen.
Electric steelmaking has seen remarkable advancements, particularly with the introduction of the EAF Quantum by Primetals Technologies. This new evolution in electric arc furnaces, EAF, showcases a fine-tuned balance of charge materials, process control, cycle times, logistics, and productivity. Sustainable steelmaking is in demand more than ever, driven by challenging market conditions and the need for competitive efficiency. Primetals Technologies has developed the EAF Quantum to meet these demands, offering high capacity, maximum availability, versatile charge material processing, and a wide range of steel grades production without prolonged adaptation times. Advantages of Primetals Technologies electric arc furnaces. High reliability and innovation. Primetals Technologies ensures that their electric arc furnaces, including the EAF Quantum, fulfill contractual agreements with high reliability. The EAF Quantum is at the forefront of innovation, offering efficient and environmentally friendly steelmaking processes. Short startup periods. The user-friendliness of the system, combined with the process expertise of Primetals Technologies specialists, ensures short startup periods, allowing for quick integration into existing steelmaking operations. High quality and minimized downtime risk. The high level of standardization of the system components guarantees high quality and reduces the risk of downtime, ensuring continuous and dependable productivity. Short amortization time. Thanks to low consumption levels, high availability, and dependable productivity, the investment in EAF Quantum has a short amortization time, making it economically viable for steel producers. The EAF Quantum is designed for high efficiency, based on an optimized preheating and melting concept. This results in minimum conversion costs, maximized output, and compliance with environmental regulations. One of the standout features of the EAF Quantum is its ability to achieve energy consumption of less than 280 kWh/t, thanks to 100% scrap preheating. This is achieved through a trapezoidal shaft design and a redesigned retaining system, which allows for optimal scrap allocation and improved off-gas routing for efficient heat transfer. Key features and benefits. Pure flat bath operation. The EAF Quantum operates with large liquid heels, ensuring pure flat bath operation with minimal flicker, which supports preheating efficiency. Furnace Advanced Slag-Free Tapping, FAST, system. The FAST system, with its siphon design, allows for charging, tapping, and tap-hole refilling under power-on conditions, further enhancing productivity and reducing cycle times. Environmental compliance. The EAF Quantum is designed to meet stringent environmental standards, making it a sustainable choice for modern steelmaking. Other advanced EAF technologies. EAF Ultimate. The EAF Ultimate represents over 40 years of experience and innovation from Primetals Technologies in the field of electric arc furnaces. It offers maximum furnace performance in terms of both quantity and quality, with extremely high energy input rates of up to 1,500 kVA/T liquid and innovative RCB technology to boost performance. The EAF Ultimate provides extremely short tap-to-tap times, delivering a significant productivity boost. Located in the industrial heart of Ukraine, among its largest metallurgical plants, is the state-of-the-art Interpipe steel facility. Built at a cost of $700 million by the Italian company Danieli and launched in 2012, this modern electric steelmaking mini-mill specializes in producing steel billets. These billets serve as crucial raw material for other Interpipe plants, where they are transformed into seamless pipes and railway wheels. The steelmaking process at Interpipe Steel begins with the delivery of scrap metal, its primary raw material. Operating at full capacity on scrap metal, their electric arc furnace utilizes a charging bucket to load the furnace with the raw materials. Once loaded, electrodes are engaged, initiating the melting process. Post-melting, a layer of metal and slag forms in the furnace, with the slag draining below for removal, facilitated by robust Volvo machines capable of withstanding extreme temperatures up to 1400 degrees Celsius. Volvo machines are not just reliable but also fuel efficient, demonstrating significant savings compared to other equipment. Their operation is critical as interruptions can lead to financial losses. The loaders, operated by skilled professionals like Alexander, ensure continuous operation without compromising safety or efficiency. Alexander, with 6 years of experience, navigates the challenging task of loading molten metal into the furnace with ease, relying on Volvo's advanced technology for reliability. The coil cut-to-length line is a sophisticated machine used primarily in metal processing industries to precisely cut coils of metal into desired lengths. Here's how each component of the machine works. Decoiler or uncoiler. This is the initial stage where the coil, which can weigh up to 15 tons, is mounted. The decoiler rotates to unwind the coil, feeding the strip of metal into the processing line. It ensures a steady supply of material for further operations. Servo feeder. Once the metal strip is fed into the line, the servo feeder takes over. It is equipped with precision servo motors that control the feeding of the metal strip at a consistent rate. This ensures that the material moves through the line smoothly and accurately for the cutting process. Straightener. Metal coils often come with slight bends or curvature due to the winding process. The straightener's role is crucial as it flattens and straightens the metal strip before it reaches the cutting stage. This ensures uniformity and improves the accuracy of the cutting process. Guillotine shear. At the final stage of the process, the metal strip reaches the guillotine shear. This component is responsible for cutting the strip to the required length. It operates by bringing down a sharp blade, similar to a guillotine, onto the moving metal strip, cleanly slicing it to the specified dimensions. The shear is controlled by advanced automation systems that ensure precise cuts according to programmed parameters.
In the specialized process of glass handling, precision and safety are essential at every step. The operation begins as a custom-designed glass transport truck slowly reverses into the designated unloading zone. This specialized vehicle is equipped with a hydraulic suspension system that allows the entire chassis to lower close to ground level, minimizing the drop height and enabling smooth, controlled unloading of fragile glass panels. Once positioned, a vacuum lifting machine, specifically designed for glass, carefully attaches to the surface of panel. With calibrated suction and steady motion, the device lifts and transfers the sheets into storage. Each panel is separated by protective pads and safety spacers, placed meticulously to prevent breakage, surface scratches, or internal stress. Operators use protective gear and follow strict handling protocols to ensure both personnel safety and material integrity.